Welcome back, folks. JLand Bio here. Today we are going to continue our work in our solutions unit by talking a little bit about what are known as colligative properties. So we've really been focusing on solutions this unit, and colligative properties are properties that change based on how much solute you dissolve in a solution. So we're going to dive in and take a look at a couple of those, including boiling point elevation and freezing point depression, to get an idea of how adding a solute to a solvent can alter the chemical properties of that solvent. Here's a couple of learning targets for us for today. You will be able to understand the concepts of certain colligative properties, and you should also be able to calculate the boiling point elevation and freezing point depression of any particular substance. We have a few key vocabulary terms, which ironically I've already talked about. We're going to go ahead and make vocabulary the word of the video, since it is so important to make sure we know all of those amazing vocab terms. But we're going to look today at colligative properties, boiling point elevation, freezing point depression. So let's talk a little bit about colligative properties. These are chemical properties that are altered by the concentration of the solution. These can be things like osmosis, freezing point, boiling point, those types of things. You ever really think about why we add salt to roads? Well, what that does is that creates a solution. The salt actually gets into the ice, and as a result of that, it actually lowers the freezing point. If the freezing point is lowered, then ice won't form at 0 degrees Celsius. It might form at -2 or -4 degrees Celsius. Thus, the ice melts at certain temperatures. This is really beneficial because we don't want to be slip sliding around the roads in winter. Same thing with boiling point elevation. A lot of times when you're making pasta, they'll ask you to add a little pinch of salt to your water. Now, while that also adds a little bit of flavor to your pasta, it also elevates the boiling point a little bit. Thus, your pasta cooks at a higher temperature. If it cooks at a higher temperature, it is going to cook slightly faster than if you didn't add the salt to it. So when we look specifically at freezing point and boiling point, when we add an impurity to any water, it alters the freezing and boiling point. This value is based on what's being dissolved and the concentration of solution and the solvent. So we're going to look at all of these things and plug these into an equation to help us understand how much the freezing point and boiling points are altered based on the concentration of certain solutions. So if we take a look at the freezing point and boiling point values, we have a couple of things here. We're going to use Kb or Kf, and that is a constant value that's based on typically what you're trying to dissolve something in. So it could be for water, depending on whether it's polar or non-polar will depend on our solvent. But that is a constant value that will be given to you. We have lowercase m, which is a molal concentration. So remember, that is moles of solute divided by kilograms of solvent. We should be able to go through and calculate that. I is known as the Vant Hoff factor, and that is the number of atoms that the compound will break down into. Remember that ionic compounds break down into the number of species in the compound. Covalent will always be 1 because, remember, it's a non-electrolyte. It does not break apart into solution, whereas electrolytes do. We need to think about what the I value is going to be for those. So we need to make sure we're able to identify a compound as either ionic or covalent. The T is going to be your change in temperature. This is the exact same slide as the one before. The only difference is I put in temperature. So with temperature, remember, that is your change in temperature. It's delta TB or delta TF, depending on what you're looking at. So that will be what's changed, and then we can look at whether we're looking at boiling or freezing and add or subtract just based on the information that's given. So let's take a look at this first question. It says, what is the freezing point of a solution containing 210 grams of glycerol in 350 grams of water? The Kf value is minus 1.86. So we know we're looking at freezing point, so we need to keep in mind our formula is that our change in temperature is equal to, we're looking at freezing point, so it's going to be Kf times our molality times I. Okay? And so if we look at the substance we're dissolving, that is covalent, so I is going to equal 1. Okay, so we're off to a good start here. Our Kf is negative 1.86, so we know that. Now we just need to figure out m. Remember, m is molality, so remember that's grams of solute. I'm sorry, it's moles of solute over kilograms of solvent. So we're going to need to calculate that. So we're going to have to convert this into moles, and we're going to need to convert that into kilograms. Which that one's pretty easy. We take 350, remember that's in grams, okay, grams into kilograms. You should know by now 1,000 grams in a kilogram. So we're going to end up with 0.350 kilograms. So we need to take 210 grams of glycerol and convert that to moles. So we're going to start over here. So we got 210 grams C3H8O3. Need to get the molar mass of that. We find that information on the periodic table. So we get 92.11. And that's going to give us moles, so we need to divide. What we end up with is 2.28 moles of glycerol. And remember, to get molality, we take moles of solute and we're going to divide that by our kilograms of solvent. So we're going to divide that by 0.350 kilograms. So we'll take 2.28, we're going to divide that by 0.350, and what we get is a molal value of 6.51 little m. Okay, and we're going to take that number and we're going to plug it right in there. So what we get for our final equation, delta T equals minus 1.86 times our molality, 6.51, times our value for I, which is 1. So take so what we get is minus 12.1 degrees Celsius. And now let's know the freezing point. Since our main solvent is water, remember our freezing point is 0. So what we would do is we'd take 0 minus 12.1 degrees Celsius. So our temperature is minus 12.1 degrees Celsius. Okay? I know there's a lot going on here. It looks really, really busy, but hopefully you followed along with me. It's pretty straightforward. Let's move on to the next practice problem. What is the boiling point of a solution containing 210 grams of sodium chloride? I keep forgetting that first G. 210 grams of sodium chloride, NaCl, and 350 grams of water. Again, it's the same concept here. We're looking at boiling point. Okay, so we're going to use the same formula. So we got delta T equals Kf times our molality times I. We're looking at sodium chloride now. Remember, that is ionic, right? So we need to think, how many things is that going to break down into? Basically, it's the number of atoms that are in the compound. So in this, your Vant Hoff factor is not 1, but it is 2. Because remember, when we put that into solution, we get Na plus and Cl minus ions. Same concept here. We're going to need to convert that to moles, and we're going to need to convert that to kilograms. Okay, so just go through the process and solve. So for that, again, it's almost the same as the last one. We got 0.350 kilograms. Okay, we need to get 210 grams of sodium chloride. And into moles. Again, we find that information where? You should all be going, periodic table, Mr. Lamb. Like, yep, don't you forget it. So our molar mass is 58.44. That'll give us how many moles we have. So basically 3.59 moles of NaCl. Remember that molality is moles over kilograms, so we're going to take that, we're going to divide that by 3.50. And we'll get our molality. And that is 10.3 little m of NaCl. Now we just need to plug everything into that top equation. So we've got delta T equals our Kf value this time. The issue though is we're dealing with boiling point, so this is actually a Kb value, not Kf. But we're going to have 0.51 multiplied by our molality, 10.3, times our Vant Hoff factor, which in this case it is 2. All right, we're going to do that, and we're going to get our temperature change. In this case, our temperature changes 10.5 degrees Celsius. Now again, we want to know the actual boiling point. Remember that we're looking at our solvent. It is water. So in order to get the actual boiling point, we're going to add 100 degrees to this, because the boiling point of water is 100 degrees. So 110.5 degrees Celsius is our new boiling point. Okay? So again, pretty easy math, but we just need to make sure we know how to read through the process and take it one step at a time. Let's do one more practice problem. The last bit we're going to look here is a little bit different type of problem, but the same concept. So we have a water solution that contains an unknown concentration of a glucose solution and is found to have a freezing point of 0.23 Celsius. What is the molal concentration of the solution? So this is a little bit different. We're asking for the molal concentration, so we're solving for M. So what we need to look at is we need to look at the change in temperature. Again, we're looking at freezing point, molal, and I. So we should be able to get the other three variables and solve for M. Well, our change in temperature has a freezing point of minus 0.23 degrees Celsius. So you know that that is below 0. So our change in temperature is minus 0.23. Our Kf value is the same as what it was before. It's 1.86. Sorry, minus 1.86. And again, that's because the glucose solution is dissolved in water. It'll probably tell you that more in some of the practice problems we'll look at. Our molality is unknown. And our I value, that's determined by looking at what we're dissolving. It's covalently it's a covalent compound. So our Vant Hoff factor is 1. So we plug that in. And now all we do is we just algebraically solve for M. It's pretty straightforward. Keep in mind I can give you other information than ask for how many grams are dissolved or how many kilograms of solvent there are. There's lots of different ways that we can go through and solve for these types of problems. Okay. So just by doing this, we get our molal concentration is 0.123 little m C6H12O6. Okay. So again, pretty straightforward problems there. Just take your time going through them, read each question very carefully, identify what you know and what you don't know, and then you should be able to fairly easily do the math and solve. So long story short, keep in mind that colligative properties are properties that change based on the concentration of the solution. And those are things like freezing point depression and boiling point elevation. And we can do calculations to be able to solve those. We just need to make sure that we know our constant. Maybe given a molality. Remember, molality is moles of solute divided by kilograms of solvent. And then we need to look at our Vant Hoff factor, and that's determined by whether it's ionic or covalent. And if it is ionic, how many individual atoms are in the compound. Great. Hopefully you guys got those learning targets. We'll practice with this a little bit more in class. I hope you have a great day. And 3 more videos this unit, and we will be done. So we'll talk to you later. Have a great day, guys. Bye-bye.